Linear model. This section will introduce a standard supervised model, linear supervised model. The core idea of linear supervised model is demonstrated in the formula, where x is future and w is corresponding weight. The relation between future and target y is linear. Linear model can be built for resolving problems for linear classification and linear regression. Logistic regression is a simple linear classification algorithm that predicts the probability of a binary response belonging to one class or the other. It employs logistic function to implement classification. If the output of logistic function is greater than 50%, then the model predicts that the instance belongs to the positive class, otherwise the negative class. It is a good baseline for binary classification. One point emphasized is that it is a classification algorithm rather than regression algorithm. The output of this function is an S-curve instead of a straight line that makes it a natural fit for dividing data into groups. Specifically, the probabilities describing the possible outcomes of a single trial are modeled with the logistic function. For logistic regression, when the hypothesis outputs some number, we can treat that number as estimated probability that y is equal to 1 on input x. In a binary classification, we use a different hypothesis, predict the probability that a given example belongs to the class 1 versus the probability that it belongs to the 0 class. 1 or positive is an example of malignant tumor, while 0 or negative is an example of a non-malignant tumor. We use sigmoid function to transform the linear calculation to probability. The right figure shows the curve of this function. The function will squash output z to a range of 0 or 1 that can be treated as probability. To learn the parameter theta of linear model, we have to build a loss function. There is a guide to tune the parameter. Here is an example of loss function, cross entropy loss, where yi is the target level and xi is the ith sample, and we can apply maximum likelihood estimation to learn theta. For linear regression, its output is a continuous value, which is the main difference to linear classification. Compared to linear classification, we will employ mean square error as the loss function to learning the parameters w. Thank you.